Hello, what we're going to do today is look at some of the new COPA compatible features that we've added to the Nova platform. We're going to start by going into our communications configuration, and we're going to add a Modbus TCP master driver just to get us some data into the system. I'm going to add a device here. This is going to be 192.168.1.141, which I know is a little Raspberry Pi sitting next to me. And then I'm going to add what we call an ordered group that lets us read a sequential block of registers. So from 40,001, let's read 4 registers. Now we can go ahead and save and commit this configuration. And if we go to our home page, we can now see that our Modbus master is running. And if we look at the device and the group status, we can see the data there ticking over nicely. So now let's go back into our communications configuration and let's add the OPC UA server. So I'm going to bring that to the top of the list, and under Advanced I'm going to turn on the COPA features with the Advanced mode, and now I can save and commit this. So now I can see my OPC UA server is running. It's idle because there's no clients talking to it, but if I open Unified Automation's UA Expert, I can click on my little server here, open it up, connect to it. Of course we have the usual certificate dance, and now we can see under the All folder we have our Modbus device. And under each parameter now we have the engineering unit range. Now this is implied because of the data type. We're dealing with a signed 16-bit value here, so it's automatically giving us the appropriate range for that. If we go back into our communications configuration, and if we look at parameter 1 for example, we can come into the limits tab and we can set a manual limit on here. So for there, let's go 0 to 1000. For P2, let's go, I don't know, 0 to 2000. And now we can save and commit once more. And now if we go back to UA Expert, and we can now see we've got those values in there. So we've got a low and a high value, 0 to 1000, 0 to 2000. So that's easy enough. We can take data out of legacy devices and expose it. But now let's come in here and on P1, let's set the unit. So we're going to select temperature and Celsius for P1. And on P2, from our unit subsystem, I don't know, what are we going to use? Let's use linear velocity, and we'll do meters per second, right? That's as good as anything else. And we're going to save and commit. This time when we go back into UA Expert, we're going to have to rebrowse because, of course, now there is a new node that's appeared, so we'll rebrowse. And now we can see we have our engineering units set up there. And those are showed both in human readable and in the CFACT form that is required by the standard. So now we've very easily taken some Modbus data and exposed it with our engineering range and our engineering units. We can do a very similar thing, for example, with an Allen Bradley device. So here I've got an Allen Bradley PLC sitting next to me. I know the IP address. I'm going to save and commit this, and then when I go back to my home screen, I'm going to see that it's connected, and I can just use our tag browse here to copy the tag list onto the clipboard, come back to my configuration, paste it in, and now when I add a group here, a scalar group, which is just a list of values, right? I have the ability to come in here and select from the tags that are in the PLC. I'm going to select all 4 of these. I'm going to add them. Now here it's a little bit different because we don't know a priori what the size of the data is. So we can't do it based on the number of bits, so we have to put the limits manually. Here we'll go from 0 to 5000, and I don't know, for this one, let's use 0 to 10,000. And then if we save and commit that, and we can flop back into UA Expert, we're going to rebrowse, and now we can see there's another PLC. So very easily we've got that information from an Allen Bradley PLC, and we've exposed the engineering unit range in the standard form. Now if we flip back in again and go into number 1, let's set some units on here. I don't know, what are we going to use? Let's use volume, and we'll do cubic millimeters. So that's cubic millimeters. We'll commit that. And our full unit system handles just about any unit of measure and any particular measurement that you're interested in. Here we'll rebrowse again, of course, to expose that. And we can see there it is. There's our engineering units, and it's got it in both formats, both the code number and the human readable form. So one more thing I can show you here. This is an MCore, which is a Monaco product that also runs Nova. And this is connected using Cat Data Link to a Caterpillar engine, or rather to the ECM from a Caterpillar engine that's sitting on my desk. So these numbers aren't doing much, but it shows you the kind of data that we can pick up. And we've got a lot of these things deployed at compressor stations and things like that. And if I go to the OPC UA server that is on there that is configured to use this new advanced mode, I can connect to that. We'll do the little certificate thing. And then we'll be able to see all of those data values. And that driver is a bit special because that driver, like our J1939 driver, for example, knows already what the units are and what the engineering range is. So if we look at effective rack, for example, we can see the value, which isn't very interesting because it's not connected to anything, but we see a low and a high of 0 to 60, and there we see it's in millimeters. And again, if we look at the effective rack limit, same thing. So all of those parameters are automatically conveyed by the driver with the metadata attached already. So as you can see, it's pretty simple. You can use any of Nova's drivers and either explicitly provide the units of measure or the range, or for advanced drivers that know that already, use the information that they collect from their sources. So that's it. Thank you. Goodbye.